Okay, so guys, what's going on with today's lesson? We're just going to get some more practice with these principles we learned yesterday. And if you look at the top corner, the top right corner, I've written down really the three primary formulas that we were using. The a sub n equals a sub 1 plus n minus 1 times d is the nth term of an arithmetic sequence. You can find very quickly using that. The s sub n is the sum, the partial sum as opposed to the infinite sum. S sub n is n over 2 times a sub 1 plus a sub n. We use that a lot. We also have this alternate form written right below it. And let's just immediately jump in to this problem. Number one, a ceramic tile floor is designed in the shape of a trapezoid. And it's 20 feet wide at the base, 10 feet wide at the top. The tiles, which are 12 inches by 12 inches, now immediately, maybe you've noticed something very subtle. The oldest trick in the book, changing the units. Please watch out for that. That can get kids into so much trouble. Reading through this very carefully, you might notice, well, wow, each little individual tile, you can see it's alternating between a yellow tile and a blue tile. But each one of those is 12 inches long. So you could, if you wanted to, take your 12 inch by 12 inch. We know that 12 inch is really what? Really 1 foot. So I've got one tile being 1 foot by 1 foot. It's a square foot. And down below we've got 20 feet wide. And at the top, we're 10 feet. So let me ask you this. How many tiles do we have on the bottom then? 20. And how many do we have at the top? 10. So very quickly you could see we're trying to see how many tiles are required. But if we kept reading this, the tiles are 12 inches by 12 inches or 1 foot by 1 foot. There's another way we could look at it more appropriately. Each successive row contains one less tile than the preceding row. Wow, so if I start off at the bottom, there are 20 tiles. The next row would have what? 19, because there's one less tile. The next row after that would be 18. And we're going to keep going until we get to the end at 10. So I know my first term in this pattern, you could say, is 20. When I'm dealing with one less tile, this pattern would be that my common difference is -1. The question is, what exactly do we have here for our nth term? Now, you can, of course, go back up here to say that a sub n is equal to a sub 1 plus n minus 1 times d. You can say, look, I don't know what n is off the top of my head. Many of you probably see it immediately. But I think this is worth talking about when it's not so obvious. Our first term would be 20. And right now our common difference would be -1. And we could figure this out pretty quickly. I would probably subtract a 20 from both sides right now. And 10 minus 20 is -10. And hey, listen, of course you are certainly free to distribute that -1 all the way through, but I'd much rather divide by -1. And that would leave me with the equation 10 is equal to n minus 1. Guess what n is? 11. This is the 11th term. This is the 11th term. Now, some of you probably just figured that out really, really quickly just without that formula, maybe just with common sense. But this formula can be a lifesaver, especially if your common difference might involve fractions or decimals, right? So that can really come to your rescue. Well, in any event, we're trying to add all these up. We want to know how many tiles are going to be used. We've got two forms to add up. Which one do you think might be the easier one to use right now, the first or the second? Probably the first. I mean, I know my last term, and I know how many terms I've got. So we're almost done here. Look, this is a Gauss's formula, really, right here. We can say, hey, I'm adding up these 11 rows. Here's 11 over 2, and my first term is 10. My first term is 20, last term is 10. And 20 plus 10 is 30. So it's 11 over 2 times 30. 2 goes into 30 15 times. And then we've got 11 times 15. What's 11 times 15? 165. You know the trick to multiplying by 11, don't you? Take down your 1, take down your 5, add them together. What do you get? You ever see that? What's 17 times 11? 187. Wow. Hey, wait a minute. What's 234 times 11? Well, now you add up here 5. Oh, it's 2,574. Isn't that nice? Pretty cool. Pretty cool. Wow. All right. Well, listen, we're making a video. We want to be good with our time. We could talk some more about that. But listen, you've got an arithmetic sequence. And they're saying, find x so that that is so. Sometimes kids look at that and they're like, well, wow, I don't know a single value here. I don't know a single term. How on earth do I work this through? Well, you know, one of the biggest things that you're talking about is the common difference. 3x plus 2, when I subtract 2x, that should get me the same thing as subtracting 5x plus 3 minus 3x plus 2. That's the common difference idea. Anytime you write out an arithmetic sequence, you take any two consecutive terms, take the larger term minus the smaller, you'll always get your common difference. Now it becomes a very simplistic equation to solve. 3x minus 2x is a 1x. Hey, we better distribute that negative and clean this up. Let's see here. This right-hand side becomes 2x plus a 1. Maybe minus an x from both sides. Got x plus 1. And now we can subtract a 1 and very quickly see that x equals 1. Go ahead, plug it in and see what you get. What does 2x become? It becomes the number 2. Plug in a 1. 3 times 1 plus 2. That becomes a 5. Plug in a 1. 5 times 1 is 5. 5 plus 3 is 8. Is this, in fact, an arithmetic sequence? Oh, you bet. What's the common difference? 3. All right. Last one. Love it. Love this one. This is fantastic. Listen, as you're working through this, how many terms must be added in an arithmetic sequence? Now, when they're saying added, they're saying, really, you're using your series, so we're going to use our S sub n formula somewhere. First term is 78. Common difference is negative 4. And you want to add up to a sum of 702. Wow. So I've got a sub 1 is 78. D is negative 4. And, wow, I know I'm supposed to add up to 702. Usually kids refer back to the top here, and they'll say, wow, look at those formulas. Which one do you think would be the most useful? The first, second, or third here? What do you think? The third. I know what I'm supposed to add up to. But do I know what my final term is? Do I know what my nth term is? I know my first term, but I don't know my last term. If I know my last term, we can use that Gauss's formula. So instead, you know what we really want to do, guys? We want to go here. We want to use that one. So, let's see where we're going. That formula is S sub n over 2, here's 2, a sub 1 plus n minus 1 times d. And you can say, well, I know I'm adding up to 702. And here's where kids get a little upset. They'll say, wait a minute, I don't know what n is. In fact, that's what I'm supposed to find. That looks a little weird. I'll leave that as n. Here's 2 times 78 plus, here's another n minus 1. And d is negative 4. And sometimes kids look at that and understandably will say, wait just a minute, this looks like it's a mess. Yeah, it does. Tell you what, let's clean it up. Let's clean this up a little bit. 2 times 78, or, well, you definitely could do that. You could also just distribute a 1/2 into the big brackets as well. Do you see how that might help? Would you like to do that instead? Maybe distribute a 1/2 in there? Somebody might be like, what are you talking about? Saying take that 1/2 and just move that in. I'd say, why are you doing that? Because it's going to make our lives a lot simpler. Look, the 2 and the 1/2 are going to go away. You're just left with 78. What's 1/2 of negative 4? Negative 2. And I could distribute that in and get negative 2n plus 2. Wow. Still looking bad. By the way, you could have cleaned everything up and then distributed n over 2 in there. Look, 78 plus 2 is 80. And then you can distribute your n. And all of a sudden, it doesn't take too long for kids to realize, hey, wait just a second, I've got a quadratic. Move this 2n squared over. How about we add a 2n squared to the right? How about we minus an 80n? And, oh, this is interesting. All of these terms are even. How about I divide everything by 2? And, my gosh, what's half of that? Is that 3? 702 divided by 2, right? We could do that pretty quick, right? We know that's just 351. And then kids can hit the panic button. They're like, oh my gosh. What do? Quadratic formula. Now, I hate to say it, every time I turn this calculator on, any program gets erased. You guys type it out for me, though. Otherwise, you'd have to try to factor it. But try that. Run your quadratic formula. What do you get? Does anybody have the quadratic formula here? All right. It's possible that you could get more than one answer. We're seeing that right here. Okay? So that's the final answer. Whether you wanted to have distributed the 1/2, you could have multiplied both sides by 2 and worked it out differently instead. But that's all we're really doing for today. Just a whole bunch more practice.